Hello, this is Jason Nieto, and today we'll be going over multiple choice in preparation for the AP Calculus BC examination, 9th edition, by David Letterman. I will be doing sample examination 2, multiple choice questions 1 through 11, and 45. Let's start off with question 1. For differential functions f and g, f of 2x equals to g of 4x for x is greater than or equal to 0. Which of the following statements is necessarily true? Now, the first thing you should notice is that it says differentiable, so you're going to want to take the derivative of both sides. And as you see, there's a 2x in here, so we need to do some chain rule, which is pretty simple, and do the same thing for g of x. Now, what College Board likes to do for all their MCQs is put the answers in simplified forms. So what we're going to have to do is divide by 2 on both sides. This 2 cancels, and you're left with f prime of 2x equals to 2g prime of 4x, which is option. Question 2. The table above gives values of a function f and its derivative at selected values of x. If f prime is continuous on negative 2 to 2, what is the average value of f prime on the closed interval negative 2 to 2? Now, the first thing that should pop out of you is average value, and if you recall, that's just 1 over b minus a of the integral from a to b of the function. Now, in this case, it's asking for the average value of f prime, so we're going to use f prime, and we're given the bounds, so it's 1 over 2 minus negative 2, and the integral of negative 2 to 2 of f prime x dx. So this double negative is a positive, so that's 1/4, and then the integral of the derivative is just f of x negative 2 to 2. I'm going to move up here, so we're left with 1/4 f of 2 minus f of negative 2. So we're given the table. F of 2 is just e, f of negative 2 is a, and then this all has to be times 1/4, and so it's e minus a over 4, which is option A. Question 3. Let C be the curve defined by the parametric equations x of t equals to 2t squared plus t minus 1, and y of t equals t squared minus 3t plus 1 for negative infinity to infinity. For what value of t will the line tangent to the graph of C have a slope of 4? Now remember, in order to find a line tangent to the graph with a specific slope for a function, for a curve defined by parametric equations, you need to remember that dy dx is equal to dy dt over dx dt. Now, dx dt is just the derivative of x of t, and dy dt is just the derivative of y of t. So you have dy dx equals to the derivative of y of t, which is 2t minus 3 over the derivative of x of t, which is just 4t plus 1. Now it's asking when the slope is 4, so all you have to do is make 4 dy dx, set it equal to what you just found, which is 2t minus 3 over 4t plus 1. Do some cross multiplication, so you get 16t plus 4, because you need to distribute the 4 to both those terms, is equal to 2t minus 3. Now this is just simple algebra. Move the 2t to one, move all the t's to one side, move all the constants to the other side. So you're left with 14t equals to negative 7. Divide both sides by 14. And you're left with t equals to negative 1/2, which is option A. Question 4. If f of x equals to 2 plus 3x to the 4th power, then the 4th derivative of f at x equal 1 is, now we have to do the derivatives a couple of times, so let's first do the first derivative. So remember, this is chain rule, so you bring the 4 down, leave the inside the same, reduce the power by 1, so this is cubed, and then do the derivative of the inside, which is just 3. Now we're going to do this 3 more times. We have to evaluate it at x equals 1, and well, there's nothing to plug in, so what we have to do is look at all the answers, and they're all in factorial and in the exponent form. So you have to recognize that 24 is 4 factorial, 27 is 3 cubed, but times 3, so you add a power to it, is 3 to the 4th, which is option B. Question 5. At what values of x does f of x equal x to the 4th minus 8x squared have a relative minimum? Now, when you hear relative minimum and you're given a function, the first thing you should probably do is take the derivative of that function, which is just 4x cubed minus 16x. In order to find relative minimums, you set f prime of x equal to 0, and you should also do some factoring. Now, you can set up a number line, or do the box method. I prefer to do a number line here. And you test values in between numbers. So let's test -3 first. And when you test -3, you get a negative. We can test -1 here. When you test -1, you get a positive number. Let's test 1. If you test 1, you get a negative. And if you test, let's say 3, because it needs to be greater than 2, you'll get a positive. Now what I like to do is draw lines, just like to indicate decreasing or increasing. It's better to visualize. This is decreasing, and this is increasing, decreasing, increasing. So we can see that the minimums are at x equals to -2, x equals 0 is a maximum, and also x equals 2, so that gives us answer C. Question 6 is just evaluate this integral. This may seem hard at first, but you have to recognize this is integration by parts. So you have to set something equal to u, something equal to dv, and then find v and du. Remember, the acronym we use is LIATE. And, well, are there any logs? Yes, ln x. So, you set that equal to u. You set the rest equal to dv. And then you find du and v. Du is just a derivative of u, which is 1 over x dx. And v is the antiderivative, which is just 1/3 x cubed. Remember, the equation is uv minus the integral of v du. So when we plug in, we get ln of x times 1/3 x cubed minus the integral of v du. So when we simplify, we get 1/3 x cubed ln x minus 1/3 the integral of x squared. So we get 1/3 x cubed ln x minus 1/9 x cubed. But since we're given bounds, there's no plus c, and we're gonna have to evaluate some things. So, as we see in our answers, we need to put these all under a common denominator. So now we can put these all under the same denominator. 3e cubed minus e cubed is 2e cubed, then plus 1 all over 9, which is answer C. Question 7. what is the radius of convergence of the series you see here? So if you remember, in order to solve for a radius of convergence, you have to do limit as n approaches infinity of the absolute value of a n plus 1 over a to the n. So we can just plug in. Now, using some simple algebra, we can break it up. Now you can see that some things cancel out. The x minus 1 to the 2n cancels out. The 6 to the n cancels out, and you're left with this. Now, you can take the x minus 1 squared out because there is no n terms in it, so you're left with absolute value of x minus 1 squared, limit n approaches infinity of the remainder, which is just 1 over 6 for the first, which we'll just do as 6. There's also no n's here to plug in since they all canceled out, so you're left with absolute values minus 1 squared times 1, 6. And in order for a series to converge using the ratio test, it needs to be less than 1. So you multiply both sides by 6, you're left with minus 1 squared. We can drop the absolute values because a square won't make anything positive, and then you root both sides, left with x minus 1 less than radical 6. Just because we dropped the absolute value means we still have to count for it. So you also have to make a one where it's greater than negative root 6. So you're left with x is less than root 6 plus 1. Remember they're not under the same thing, so put parentheses, and 1 minus root 6. Now as you can see, there's a positive 1 on both sides, and it only varies by rad 6. Positive rad 6, negative rad 6. So you can see that the radius is just root 6, and that is your answer. Question 8. The function x to the 4th plus bx squared plus 8x plus 1 has a horizontal tangent and a point of inflection for the same value of x. What must be the value of b? So we know a horizontal tangent is when the numerator of the first derivative is 0. As you can see, we won't have a numerator of the first derivative, so it'll just be the whole thing equal to 0. Now it also says there's a point of inflection at the same point, so we have to do the second derivative, so y double prime is equal to 12x squared plus 2b. Now, this is a system of equations. You could solve for either x or b. I'll personally solve for b. I think it's easier because there's going to be either weird factoring or radicals. So let's just solve for b. Is your b, negative 4x cubed minus 8 over 2x. So now you can just substitute this into y double prime. Remember, a point of inflection is the second derivative is equal to 0. X equal to 1. Now it's asking for the value of b, not x, so we're just going to plug in x to the b equation we found here. Equal to negative 6, which is b, and a is your answer. Question 9. Let y equals f of x be the solution to the differential equation dy dx equal to y minus x. The point 5, 1 is on the graph of the solution to this differential equation. What is the approximation of f of 6 if Euler's method is used, starting at x equal 5 with a step size of 0.5? So, remember Euler's method is the table like this, where you have your starting x, your y, and then you have your two steps here. You're solving for x equals 5.5 because it's asking for a step size of 0.5. And you'll end up with 2, 6 because you're finding that. You're given your starting value of 5, 1, and your equation is just y equals to y minus x dx, all you're doing is multiplying dx to the differential equation on both sides. Dx is always 0.5, it's just change in x. So now we can start solving for f of x. So using your initial condition, it's y, which is 1, minus x, which is 5, times 0.5, which is just equal to -2. Now you're going to add, or in this case, subtract from your starting value, so you'll get -1. So you're going to use this next point, 5.5, -1, for the next step. And you get -4.25, which is A. Question 10. The figure shows the graph of y equals f of x and y equals t of x, where t of x is a Taylor polynomial for f of x centered at 0. Which of the following statements must be true? Let's take it one at a time. Statement 1. T of 0.5 is a good approximation for f of 0.5. Let's find a rough point where x is equal to 0.5. We can say it's like right around there. And we can see that t of 0.5 and f of 0.5, they're either the same value or very, very, very close that it wouldn't be noticeable on a graph like this. So t of 0.5 is a good approximation. Statement 2. T of 1.5 is a good approximation for f of 1.5. Now you can see at around x equals 1, t of x splits off from f of x, and if we find the rough estimate for 1.5, we can see that they're very apart from each other, so t of 1.5 would not be a good approximation. Statement 3. T of 0 equals f of 0. Since the Taylor polynomial is centered at 0, they need to know what f of 0 is and any other derivatives at 0. And when you plug in x, so let's say we have a Taylor polynomial like this, right? When you plug in 0, you'll just get the f of 0 value. So t of 0 is equal to f of 0. So that means statements 1 and 3 are true. So that means choice D is the correct answer. Question 11 is just asking us to evaluate this limit. So let's just plug in for 2. And when you solve this, you get 0, because 2 squared is 4, minus 4 is 0. And if the a and b bounds are the same, you'll just get an integral equaling 0. So you can use L'Hopital's, because it's a 0 over 0 situation, to solve the answer. You get a limit as x approaches 2 of 2x over, while the derivative of an integral is just the function, but you can't just leave a t there. You have to plug in for x, because when you evaluate this integral, using the fundamental theorem of calculus, all you do is plug in the x to the t, and you do the derivative of x, which is 1. So you get cosine of pi x, and you just plug in 2 for x, so you get 4 over cosine of 2 pi, which is just 1. Your answer is 4, and it's option choice C. Question 45. The tangent line to the graph y equals e to the 2 minus x at the point 1e intersects both coordinate axes. What is the area of the triangle formed by this tangent line and the coordinate axes? Let's take this one step at a time. First, let's just solve for the tangent line. So first we're going to do the derivative, so y prime equals to derivative of 2 minus x, which is -1, and then e to the 2 minus x. So now we're given a point to use, so which is 1e, so let's plug in 1, which is just -e, 2 minus 1, which is just -e. So now we can make a tangent line equation, so it's y minus y1, which is e, equals to m, which is -e, x minus x1, which is just 1. So we can distribute. This will make our life easier later. Add e to both sides, and you're left with negative e to the x plus e, which is just negative e to the x plus 2e. You can see that this is a linear function that is decreasing, that starts at 2e. So what this looks like, it starts around here and it just decreases, and this is the area you're looking for. So in order to find the height and the width, you just have to plug in x equals 0 and y equals 0 for both of them, because your height is just when it intersects the x and y axes. Let's plug in a y equals 0 first. So x equal to 2, and when you plug in x equals 0, you get y equals to negative e times 0 plus 2e, which is just y equals to 2e. And then these are your heights and widths. So if you remember, area of a triangle is just equal to 1/2 base times height, so times 2. 1/2 times 2 times 2e. 1/2 and 2 cancel, so your area is just 2e, which is answer A.